All right, we are going to be discussing graphite. Graphite is another giant molecular, which means covalent structure. Okay, all right. Things that we need to understand about graphite is what graphite is another allotrope of carbon. All right. It is made up of layers of carbon atoms. Okay? Within each layer, this is an important point. Within each layer, each carbon atom forms within each layer, each carbon atom forms covalent bond with three other carbon atoms. Let's take a minute here to understand this. I want everybody to stop writing and see this. We know that carbon is in group. Carbon has. Can anybody tell me what is the number of carbon? The atomic number of carbon? It's 6, right? If you make a configuration, you're going to see it is 2 and 4. 2 and 4 represents what? That each carbon atom has 4 unpaired electrons. Do you see the importance of making electrons in this manner? Remember, for oxygen we used to make like this, so that we can get to know how many unpaired electrons are there. Similarly, when we are going to be making 4 electrons for carbon, they all are unpaired. It means that they all are going to be involved in bonding, right? We know that unpaired electrons are the ones that are involved in bonding. So if you look at diamond, we saw that each of the carbon atom, each electron in the carbon atom was involved in bonding, right? If you look at each carbon atom will be attached covalently with each electron of the carbon atom is making a bond. But in graphite, we see something else. We see that only three electrons get involved in bonding, and the fourth electron actually slips out and moves as a free moving electron in the layers of carbon. You understand? You what? Everybody is able to get it? How are they made? This is how they are. You see, can you see this? How are they made? Is this making sense, everyone? This is how these carbons are formed in layers. Okay, in layers. This is one layer. And then there is going to be another layer. Is this making sense? This is how they make in layer. And each, you if you look at it, only each carbon is only making bonds with three other carbons. What about the fourth electron? What about the fourth electron? What about the fourth electron? What about the fourth electron that was supposed to be making bond? They all go out. They all leave the carbon, and they go in between the layers. Where do they go? They go between these carbon layers. You understand, everyone? Or should I draw it with the other with another color? Eileen, are you able to get it?
Yes.
They go, all of them, they go between these carbon layers. Similar. This is one carbon layer. This is one carbon layer. This is another carbon layer. Similarly, there's going to be another carbon layer like this. If you look closely, you will see that each carbon is going to be making only three bonds. So the electron, these electrons, the fourth electron from each is going to be there out between these carbon layers. This gives graphite the sea of electron, because we see the sea of electron only where in metals. We see such layers of, we are going to see such layer of atoms with. We are going to see such layer of atoms and then electrons in between in metals. Everybody gets this? We see metal ions, they form positive ions, and the sea of electron is between those layers of metal ions. So that is the reason the graphite has the same kind of properties generally when we are going to see this. Is this clear, everyone? Everybody has written this, drawn this, or something? You don't need to really draw this. If you want to, you can take a picture of it. All right, you take a picture of it, graphite structure. You should know this. We are going to be discussing the properties. The properties. All right. So the graphite, so graphite is a solid. Graphite, number one, is solid. Number two, it is dark in color, black, right? Dark in color because it does not allow electric light to pass through it, right? And number three, it's soft. Soft. You'll see why. Soft because if you press it, each layer slides over the other layer because of the sea of electron, right? If you're going to compress it, if you're going to press it, if you're going to squeeze it, layer 1, layer 2, layer 3, there could be many thousands of layers. Each layer slides over the other layer because of the sea of electrons. That is the reason it is soft. You see? And that is why it also forms a good lubricant. We'll discuss about it, inshallah. And it has a very high melting point and boiling point. We'll see why. Okay. It is also a good conductor of electricity. I'll write the description for each of it. Why? All right. It is unreactive. Okay. All right. So when we were discussing the structure, let's complete that part. So we were writing about it. So it's made up of layers of carbon from here. Within each layer, each carbon atom forms a covalent bond with three other carbon atoms, right? We wrote up till here three other carbon atoms, right? So this forms this forms rings of six carbons joined together and form 2D flat 2D flat layers. Okay, two-dimensional flat layers. All right. Important point again. Each layer each layer is held by weak van der Waals forces. So the interaction between each of these layers is what? Weak van der Waals forces. Okay. Each layer is held by weak van der Waals forces. Okay, you can take a picture now again. Written, everybody has taken a picture. Alishba, Illy, Hadia, everybody has a look.
Yes, sir. सर आप एंड में फिर से सारे नोट्स दिखा देंगे ताकि मैं रीचेक कर लूं
जी
कि
सर।
मैंने
देखिएगा.
जी सर ले लिया स्क्रीन
ठीक है, very good. Now we are going to be discussing why the physical properties. All of these physical properties, the graphite is solid, dark in color, is soft, very high melting and boiling point, good conductivity, unreactive. Why are these physical properties there? We'll explain each of these physical properties. Why do we find it over there? Okay. Let's write about it. If you look at it, when we look at physical properties of graphite, right? When we look at graphite and its physical properties, we see that basically each carbon is bonded with three other carbon atoms. It is making a similar network as there was in diamond, but a little bit weaker. Why? In diamond, there were each carbon was bonding with three, four. Here, it is only bonding with three. Do you understand? That is the reason there are so many covalent bonds, and when there are so many covalent bonds in a single molecule, its melting point goes up. You understand? Each carbon is bonded with three other carbon atoms, making a network of many covalent bonds all together, right? This requires a lot of energy, obviously lesser than diamond, because in diamond there are going to be many more covalent bonds than graphite. Why? Because each carbon is making four bonds. Here each carbon is only making three bonds. This requires a lot of energy to break these bonds, to these bonds and arrangement of atoms, right? It's a solid, keep in mind, it's a solid, so its particles are arranged in a particular manner, right? Solid के particles तो arrange हुए हुए होते हैं ना एक fixed particular manner में, so they are in their fixed positions in solid. So to in order to break these bonds and make them move freely around, you need a lot of energy to break all those covalent bonds. Okay, to break these bonds and of solid solid arrangement of arrangement of solid, right? Requires a lot of energy to break these bonds and the arrangement of atoms, all right? Because there are many covalent bonds all together. This is the reason it is solid. This is the reason it is solid and has a very high melting point and obviously boiling point. All right. Graphite is soft at the same time. Is soft and slippery. 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 Yes. Why? Why? Because the layers are not held by strong forces, right? The layers are not held by strong forces, rather weak van der Waal forces, right? A slight, a very, even a slightest of the force, a slight force can make these layers slide over each other. You get it, everyone? And the third and important point, electric conductivity. Very easy, right? Very easy. Why? Due to localized free due to delocalized free moving electron. It is due to the delocalized. Delocalized, what does delocalized means? It means that it has left its place. What was its place? In the orbit, in the shell of carbon, but they came out and they formed a sea of electron moving around. Delocalized electrons moving around, right? So they are the ones that are responsible for the conductivity, electric conductivity uh, of the carbon. That's what graphite. Is this making sense, everyone?
जी।
We find graphite in many places due to it they are good as uses of graphites. Many uses due to their properties. Everybody has taken, if you have not written, you can take a picture from here. देखिएगा. Properties. Elaine.
सर पिक्चर ले लिया।
All right. All of it.
सर मुझे फिर से दिखा। Yes.
Take from here. Physical properties. This one and then the next one. Take this picture. Screenshot. And then this one.
सर एक सेकंड डिलीट हो गया गलती से, सॉरी।
No
फिर
problem.
से करेंगे। अब नीचे गए।
Done. Done. All right.
यस सर।
Let's look at uses of graphites now. Graphites, they are soft, so they can be used as lubricants. Pencil lead, they can be used for pencil lead, right? When you press it and you write to it on a paper due to friction, the chips they get chipped off and they are able to stick to the paper while you are writing. All right. They are used in motors, brushes for motor, so they are good conductors. Another important point is that graphite does not destroy rubber. Okay, it does not destroy, it does not affect rubber, does not affect rubber. Okay, so it is a good lubricant that can be used instead of oil, because oil damages rubber, it makes it hard and it cracks. You get it? So it is a good lubricant for machine parts, for places where there's a lot of friction. They can be used in pencils. Good. Good conductor of electricity. For this, they are soft, they can be for used as brushes, used as brushes for electric motors. Okay, they good conductor electricity, and they are not reactive, so they are good good for electrodes, or you can say good as electrodes for electrolysis. Good as electrodes for electrolysis. Okay, is this clear, everyone? Write this down, inshallah.